Hello everyone, and welcome to a new series on this channel, in which we'll be tackling the topic of data structures. More specifically, we'll be talking about what they are, some different types of data structures, and how we can use each of them effectively with some examples. This course will be a general overview of data structures, and so we won't be confining ourselves to one specific language. However, this series will require you to have some basic understanding of programming. If you are completely new to computer science, I would like to shamelessly plug our Introduction to Programming series, which will be linked both in the description and on your screen now. That video will give you all the information you need to traverse these topics comfortably. Additionally, and a first on this channel, for each segment we'll be including the references and research materials used to write the script for each topic in the description below. That way, if you ever feel like I haven't explained a topic well enough, or you would just simply like more information about a certain topic, you'll have a readily made list of articles and websites which you can use to supplement this series. In this introduction, we'll simply be covering a general overview of what exactly a data structure is, and then talking about what type of information will be covered throughout the duration of this series. So let's begin. So the obvious question to start off with is, what exactly is a data structure? Well, in computer science, a data structure is a way to store, organize, and manage information in a way that allows you to easily access or modify the values within them. Essentially, it's a way for us programmers to store a set of related information that we can then use for our programs. Data structures and the algorithms that are used to interact, modify, and search through them provide the backbone for many of the programs you'll end up writing. Each of the data structures we'll be talking about are designed for the sole purpose of storing information and then allowing the end user to access and manipulate that information in an efficient and effective way. But each one differs in the way that they accomplish this. Now, if you have a basic understanding of programming, you probably know about a few different data structures already, such as the array and/or the array list, which is also known as the list in Python. But if you're going to be pursuing a career in computer science, just knowing these two is not going to cut it. While basic data structures such as the array are used by companies in obvious places, like password databases or online directories, more advanced data structures, like the ones we'll be talking about in this series, can also be seen all around you on the web. The undo-redo button in Google Docs, spell check on your phone, and even text searching all require the use of more advanced data structures, which makes them extremely useful to learn and comprehend. Alright, so now I hopefully have you hooked on data structures and how useful they can be. So let's discuss the information we'll be covering in this series. Now, before we talk about any specific data structures, we're going to briefly discuss efficiency. We'll talk about the metrics that are used to judge speed and time complexity of different data structures to give you a better understanding of why one data structure might be used over another one, using Big O notation, which is the industry standard for this type of stuff. From there, we'll be diving headfirst into the basics, those being arrays and array lists. Now, while you may already have a good understanding of what these are, I highly suggest that you still watch these segments, because we'll be going into a little bit more depth of why they're so useful, based on differences in how they're stored in the computer's memory. It may not seem that interesting, but it actually provides a lot of good background on why arrays and array lists differ from each other. After that, we'll be taking a look at stacks, which are the backbone for all recursive processes in your computer. Next, we'll look at the antithesis of a stack, which is a queue. From there, we'll be moving on and covering linked lists before moving on to dictionaries, two data structures that are used for very specialized tasks. Then, we'll talk about both trees and tries, very useful data structures used for a lot of word processing algorithms. And finally, we'll be ending off the series with a discussion on heaps and graphs. So in total, I'll be taking you through 10 of the most common data structures that are practically used in computer science, as well as providing specific examples of where and when you can use them. With this knowledge, you'll be able to take it into your programming career and hopefully gain an upper edge by implementing them when needed. Like I said, however, before we jump straight into the different ways to store information, I'd like to have a quick discussion with you guys on how we score the efficiency of these data structures using Big O notation. So let's just jump right in.